This is the notes for 1.3 using linear relationships. We're going to be looking at two vocab words today because every linear relationship is going to have two variables. Okay, so let's just start with the independent is the one that determines the value of my other called the dependent variable. So for example, if I was to organize a bike tour, the number of people who registered would be what I put in, and what I get out is the cost for renting my bikes. So I'm just going to make that as a note down here. So my independent, that's my input, what I put in. In this example, I'm putting in the number of people. And what I'm getting out is the dependent variable. So in this situation, what I'm getting out is the cost of renting my bikes. Okay, so I'm going to draw a little arrow there. So every time I put in the number of people, and what I get out is the cost. The other way to look at it, the dependent variable is the one that determined by my independent variable. So for example, if I travel the distance in my car, it depends on how long I drive. So what I put in for my input is how long. We could think of that as time, and what I got out was my distance. This is going to be really important when writing an equation here in a minute. Every time what I put in, that's what's going to have my variable with something being done to it, and then what I get out, my output, is my dependent variable. I put in the number of people, I got out the cost. I put in the time for my drive, I got out my distance. Okay? This arrow will never go the other direction. Alright, so let's look at an example. Each student found sponsors who are willing to pledge money according to the following descriptions. Leanne is going to ask them to donate $10 regardless of how far she walks. Gilberto is going to ask for $2 for every kilometer. And Elena is a combination of the two. She's going to ask for a $5 donation and then 50 cents per kilometer. So my independent variable, that's my input. What I'm putting into this function is how far she walks. So her distance, the number of kilometers, that's my independent variable. What's changing as an output is how much money she's going to raise. Okay. So in each of these equations, we're going to put in a certain amount of distance, and we're going to get out how much money she's raised. So let's start with Leanne. She gets $10 regardless of how far she walks. So if she's sick and doesn't show up the day of the race, she gets $10. If she's an overachiever and goes 6 kilometers, she still unfortunately only gets $10. So Leanne's entire column, we can go ahead and just fill in $10. Okay. Leanne's distance doesn't matter. She's only getting $10 out for her money raised regardless of how far she walks. Okay. When I go to graph this, I'll zoom out a little bit, we need to make sure that we can get the distance, my input, to 6, so I'm just going to count by ones. And then what I'm getting out is my amount of money. So my dependent variable, what I get out is the money. I need to make sure I can count up to 10, so I'm just going to count by ones again. Okay. So when we go to graph Leanne's line, she's putting in 0 distance, and she gets out $10. She puts in a distance of 2, she gets out $10. She puts in a distance of 5, she gets out $10. I can graph each of these points if you'd like. Okay, but it's just going to turn out to be a straight line. Even if she walks 10 kilometers, she still only gets $10. So Leanne's is a straight line. Regardless of how far she walks, she just gets $10. So for her equation, what I'm putting in is the distance, and what I'm getting out is the money raised. So for our equation, I'm going to say M for money raised. And what that is $10. And then she gets 0 for every distance she walks. So if I was to put in 6 times 0 is 0, I would still just get out 10. I'm putting in distance, and I get out money. All right, let's try Gilberto. Gilberto is $2 per kilometer. So unfortunately, if Gilberto's sick and he doesn't show up, if he goes 0 kilometers, he gets $0. But every one he goes after that, he keeps getting 2. So at 1 kilometer, he gets $2. At 2 kilometers, $4. 3 kilometers, $6. Every time, he keeps increasing by $2. So after 6 kilometers, Gilberto is making more money than Leanne. Okay, so in his plan, 0 miles or 0 kilometers means he gets 0 money, but after 1, he gets $2 out. I put in a distance of 2, I get out $4. I put in a distance of 3, I get out $6. I put in 4, I get out 8. I put in 5, I get out 10, so now he matches Leanne. And then at 6, now he's at 12. So I should see a straight line every time he gets $2 for every kilometer walked. He gets $2 for every kilometer walked. So this is Gilberto. In his equation, his money equals $0 to start out with, but he's getting $2 for every distance that he walks. Our distance there was D. All right, let's look at one more, then we'll make some conclusions here. So Elena gets $5 plus 50 cents per kilometer. So if Elena is sick and doesn't show up, at least she still gets $5. But then every time she only gains 50 cents. So after 1 mile, she's at $5.50. 2 miles, $6. 3 miles, she gets another 50 cents. She'd be at $6.50. 4 miles, $7. 5 miles, $7.50. 6 miles, $8. Okay, so keep in mind she does start with more than Gilberto. So when she's at a distance of 0, she does get 5, but then her line's going to be a lot flatter. She only gets 50 cents per mile. So at 1, I'm going to be halfway between 5 and 6. At 2 miles, she's at $6. At 3 miles, she's at $6.50. 4 miles, $7. 5 miles, $7.50. 6 miles, $8. So we're going to connect it and make it straight. So this one is Elena's line. So she started with 5, but then her line was a lot less steep. She was only getting 50 cents per mile compared to Gilberto's got $2 per mile. So in Elena's equation, we're going to say money equals a starting point of 5, and then she's gaining 50 cents per every mile. Okay, so that's our big idea for today. My independent is what I put in. So in this case, it's my distance. I'm putting in 1 mile, 2 miles, 3 miles. What I get out is how much money she's raised. So in Leanne's example, it's always 10. In Gilberto's, he's gaining pretty quickly. Or in Elena's, it's a little bit steeper. But every time what I get out is my amount of money raised. Okay. So one thing I just want to preview here for you is the idea of slope and y-intercept. Okay, so the amount that I'm gaining every time, this determines how steep my line is. That's what we call our slope. Okay. I can see that in my graph.